Good afternoon, Algebra B students. Miss Shaw here, and today we're going to go into lesson 9.8, day 1, which is solving nonlinear systems. So if we think back to first semester, we worked in systems of equations with linear lines, so lines that were straight, whether they were vertical, horizontal, on the diagonal, but they were straight lines. They were not anything raised to a power of 1 or more. They were only raised to a power of 1. So today we're going to look at solving nonlinear systems, which means that one or possibly both of our lines that we're going to be graphing and looking at may not always be a straight line. So let's take a look at problem number 1. Consider the following system. Well, here we have the line y equals 6, and here we have the function y equals x squared plus 2. This is our system of equation. If we wanted to describe this system in words, well, y equals 6 is a horizontal line, and it is linear, horizontal linear line. And y equals x squared plus 2 is a parabola. And if we remember that vocabulary word, parabola, that is that U-shaped figure that is graphed when we are looking at quadratics, so something raised to a power of 2. Okay. For part B, it says to graph this system on your calculator and find the points of intersection. Write them here. Now notice it also has S in parentheses, meaning that there could possibly be more than one solution, more than one intersection point. So let's go ahead, let's take out our graphing calculators, okay? Just want to make sure the glare is not too bad and that you guys can see all of the buttons. So make sure your Y1 and your Y2 are cleared out. The first thing we're going to graph is just 6. Y equals 6, the horizontal line. The next thing we're going to graph is x squared. Remember, so you can use that caret sign right down here, and then you can go ahead and put a 2 there. Okay, make sure you use the side arrow to go back down, and then plus 2. And then we can go ahead and graph this. Right, so as we can see, we don't see anything. So maybe we want to zoom out. If the zoom out button does not work, then we can always change our window manually. But something does not look quite right. So let's make sure we typed everything in correctly. Yes, we did. So maybe that's why. Look at that X, max, and min. That is definitely not the right window. So maybe we want to go -10 to 10, oops. And then with a scale of 1, and then maybe -10 to 10 with a scale of 1 for y as well. And hopefully this should make this just a little bit better. And voila, there it is. Now, if you notice, this does intersect in 2 places. So we are going to have, we can kind of just like start really quickly, 2 intersection points. Okay, and let's go ahead and figure out how to find the first one. So in order to find the intersection, we are going to go to our handy dandy second trace screen. I always tell my students, if you're stuck, when in doubt, just hit second trace and hopefully one of these options will come to you. And we're actually going to go down to number 5 and hit intersect. Okay, now when it's asking us for the first curve, that is the first line, which is blue, y equals 6. We want to move the butterfly cursor over to kind of hover around the intersection point that we're trying to find. So we'll hit enter. We want to make sure that the butterfly cursor is on the second curve now when it's asking for the second curve, and we can hit enter. And then we'll hit enter again for the 3rd time. And if you look, our intersection point is at -2, comma 6. So that is the first point. Now we're going to go ahead and do that again for the second point. So we're going to hit second trace. We're going to go all the way down to intersect. We're going to move our butterfly cursor over to the other side to hover around that intersection point. Hit enter. Move the butterfly cursor for the quadratic over just a little bit. Hit enter again. And then hit enter for the third time. And our second point of intersection is 2, 6. Right? So maybe let's write ourselves a note. Once we've graphed both lines, we want to hit second trace, intersect, and then we definitely hit enter 3 times. Okay, so these little helpful hints will definitely guide us through the rest of this worksheet. So let's go ahead, let's plot what we see. Well, when we're graphing the line y equals 6, that is the horizontal line. We saw it over here on our graph in our calculator. That is the horizontal line where y is 6. So we can go ahead and we can just draw this horizontal line right here, just like that. Okay. Now for our parabola, we know it crosses the axis at 2, 6 and negative 2, 6. So those are our 2 intersection points. And if we look right here, our vertex of the parabola, okay, that minimum point is at 0, 2. So we can go ahead and plot that point right there. And if we want to, we can go ahead and sketch the parabola just like that. Now remember, when we sketch a parabola, we don't want the bottom to be pointed. We do want that rounded bottom out to make the curve. And there is the duplicate of our graph here on the paper. So now for the second part, part D, it's going to ask us to solve by substitution. And this is one of the methods that we worked through first semester when we were working in systems of equations with linear lines. So in order to solve by substitution, we do want to just rewrite out the system and see what we're working with here in terms of substitution. So here we have y equals 6 and y equals x squared plus 2. So if we take a look at both equations, we notice that they are both equal to y. So therefore, we can use substitution because we can substitute one of the y values in for its numerical or the function of y. So what we can do is we can substitute this 6 in for that y, and we can say that 6 is equal to x squared plus 2. Now, this turns into solving an equation. We can solve it by factoring. We could move the 6 over to this side and set it equal to 0. But the first thing that we notice is that there's no b term. Typically, when there's no b term, solving by the square root method is probably going to be our simplest way of going about things. So in order to solve by the square root method, we can subtract 2 from both sides, and we get that 4 is equal to x squared. Now that we have x squared isolated, we can go ahead and take the square root of both sides. When we do that, we know that x is not only equal to 2, but that x is also equal to negative 2. And there we have our 2 x values. But we're not done because we do need to find the ordered pair, right? So whenever we're solving a system of equation, we don't just care about the x value, we also want to know the y value. Now, it just so happens for us that we already know that y is 6, so really this turns into 2, 6 and negative 2, 6, which is what we found up here in our calculator. So that worked out really nicely. But if we want to make sure we check our solutions, we can go ahead and substitute that value in. Y is equal to negative 2 squared plus 2. Y is equal to 4 plus 2. And y is equal to 6. So this one works out. And then we can do the same thing for positive 2. Y equals positive 2 squared plus 2. Y equals 4 plus 2. Y equals 6. And that one also works out as well. So here is our first example problem, system of solutions where y is equal to 6 and y equals x squared plus 2. So let's go ahead and let's take a look at the next example problem. So here we see the following system, y equals x minus 3 squared minus 3, and y equals 1. Now, even though this function looks a little bit different to us, we notice that it is squared. So y equals the quantity of x minus 3 squared minus 3 is a parabola or quadratic. Okay, and y equals 1 is a horizontal line, and we should point out that it is linear. Okay, so if we take a look down below, the graph is already provided to us, right? Which is awesome. So a few things that we want to point out is one, where are our solutions, right? Where do they intersect? And if we take a look, they intersect right here at this point 1, comma 1. And they also intersect right here at this point 5, comma 1. Now, hopefully we begin to notice a trend. If we have a horizontal line as one of our systems or one of our equations in our system, your y value is always going to be the same value as that line. So for example, the line is at where y is equal to 1. So therefore, our y values of our solutions is 1. Up here in the first example, the equation of the line, the horizontal line was y equals 6. And if you notice, both y values in our solutions were 6. So now, one thing that we can do to check our work is we can solve by substitution. So let's go ahead and let's rewrite out this system. Y equals x minus 3 squared minus 3, and y equals 1. So what we can go ahead and do is we can notice that they're both set equal to y. So we can easily substitute the functions in for each other if they're both set equal to y. So we can say 1 is equal to x minus 3 squared minus 3. And there's a few different ways we can go about working through this. We could expand this out, double distribute, try and factor it. But if you guys remember from last week, we have done example problems that look like this. This equation is in a form that is known as vertex form, which is what we're going to get into when we come back from spring break. But notice that we can totally isolate this value, x minus 3 squared, and potentially solve by the square root method. So in order for us to do this, we do want to get this whole term by itself. So we're going to go ahead and add 3 to both sides. And now we see that 4 is equal to x minus 3 squared. Now that this factor that is being squared is isolated, we can go ahead and take the square root of both sides. Well, we know when we are solving that the square root is always going to give us the positive or the negative of the answer. So really what happens is that x minus 3 is equal to plus or minus 2. So how we could rewrite this out is two separate functions, right? Two separate ideas for x. X minus 3 is equal to positive 2, and x minus 3 is equal to negative 2. We can then go ahead and solve for x, and we get that x is equal to 5. We can go ahead and add 3 to both sides, and we can solve for x, and we get that x is equal to negative 1. okay? Now we can take those, plug them back into an equation and check our work here for y. Now, unfortunately, we can't plug them back into y equals 1 because there's no x term there, but we can definitely plug this into the first equation. So let's take a look at what that would look like. Y equals 5 minus 3 squared minus 3. Okay, well, if we are looking at order of operations, what's inside of the parentheses goes first. So 5 minus 3 is 2. 2 squared minus 3. Well, 2 squared minus 3 is 4. 4 minus 3 is 1. And so y is equal to 1. So if you look, here's our first ordered pair. 5 comma 1. It worked. It checked out. Okay. I'm so sorry. I'm running out of room, which is never a good thing. But if we wanted to check our work for the next one, maybe we can use our calculator for that. We'll plug in negative 1 for x. So we can say negative 1 minus 3 squared minus 3 does not give us 1. Okay, I think we just found the mistake, or my mistake, right? Negative 2 plus 3 is positive 1. Oh my gosh, Ms. Shaw. Can you tell it's an early morning when I'm making this video? Negative 2 plus 3 is positive 1. So let's try this again. 1 minus 3 squared minus 3 is 1. And there you go. So our next ordered pair is 1 comma 1. And if you look, they do match our two intersection points right there. So that's awesome. Okay. Now let's go ahead and let's work through our last example problem, number 3. And this example problem is going to have us do primarily the same steps that the first example problem did. The last one, it was really nice. It was already graphed for us. This case, we're going to have to do some graphing on our own, but that's totally fine. We should feel pretty good with the calculator. So we need to consider the following system: x minus 1 squared plus 3 and y equals 3. Well, here we have this first equation, the function is a parabola, right? It is squared. And the second function, y equals 3, is a horizontal line that is linear, right? Horizontal linear line. So again, we're going to graph this system and find the point of intersection. I'm sure we've already noticed in this worksheet that when we're graphing a parabola and we're graphing a linear line, so far we've seen intersection points twice. Now, that may not always be the case because if we think about how many solutions a parabola could have, it could have 2, it could have 1, or it could have none. So we know it's not always going to have 2 intersection points, but it is a good educated guess that that is how this example problem is going to happen as well. So let's take a look. Let's see what we find. Excuse me. So let's go ahead and let's graph this. Parentheses, x minus 1, and parenthesis, up caret squared plus 3. Okay, and make sure when you do that, you move your caret back to the side so that way you can add 3 at the end. And then our horizontal line is just where y is 3, and we can go ahead and hit graph. Okay, now, really funny that we said that earlier, because look what happens here. As of right now, it looks like we only have one point of intersection. Now, we can totally zoom in and see if that's the case. Let's take a look here. Okay, we don't see anything, so we're going to have to set that ourselves, maybe negative 5 to 5, negative 5 to 5. Okay, but it does only have one intersection point. So let's take a look and let's try and figure out where it is. Second, remember, when in doubt, second trace, go down to intersection. Sorry, there's a glare. Okay, are we on our first curve? Move it around so it's kind of near the intersection point, hit enter. Are we on our second curve? Yes, hit enter. Hit enter a third time. And if we look, that intersection point is at like 0.99999, comma 3. That's going to be interesting. 0.99, comma 3. So if we wanted to graph that, okay, well, first off, y equals 3, right? We can go ahead and just draw that horizontal line. Okay, and for our parabola, we can look at some of the table functions, second table. And if you look, y1 is that first line that we graphed the parabola. So we can go ahead and take a look. When x is 0, y is 4. I should use a different color. I'm sorry, guys. Y is 4. When x is 1, y is 3. So it almost looks like instead of 0.9993, maybe it's also kind of at 1, comma 3, you know, but we can definitely keep our eye on that, and then 2, comma 4, 3, comma 7, and then I think we kind of have a good picture of this parabola, and we can go ahead and sketch it. Now, I know our calculator gave us the intersection point of 0.99, comma 3, and in our table function, it showed up as 1, comma 3. One way that we can just quickly make sure that our work and our algebra is correct is by using substitution. I think that definitely can help. So let's go ahead and see what happens here, okay? If we are solving by substitution, we're going to go ahead and rewrite out the system. Okay, y equals x minus 1 squared plus 3, and y equals 3. So what we can do is, because they're both set equal to y, we can set them equal to each other. 3 equals x minus 1 squared plus 3. We're going to want to solve by square root method, so we can subtract 3 from both sides. When we do that, we get 0 is equal to x minus 1 squared. Even though this is set equal to 0, we can still isolate, and this term's already isolated, so we are going to want to solve for x, which is by taking the square root of both sides. When we do that, the square root of 0 is just 0, and we're left with x minus 1 on this side. So in order to get x by itself, we can add 1 to both sides, and we do see that x is equal to 1. So if you take a look, we found algebraically that x is equal to 1. So sometimes our calculators are a little off. 0.99999 repeating is very, very close to 1. So sometimes it also has to do with the window of the calculator. It couldn't really quite see that tip, the vertex of the parabola was at 1. It may have looked just a slight tad bit off, but that's okay. And then we do want to make sure that we double check our work. So we are going to plug x back in. Y equals 1 minus 1 squared plus 3. Well, 1 minus 1 is 0. 0 squared is just 0. And 0 plus 3 is just 3. So therefore, if you take a look at what we found for x and what we found for y, it is the ordered pair of 1, comma 3, which matches what we found up above. So that was just some practice with solving nonlinear systems. We went through 3 really great example problems. We also made sure that we took a look at some calculator steps. Remember, second, trace, intersect, hit enter 3 times. But other than that, we hope you guys have a great Monday night, and we will see you tomorrow in class. Bye-bye.